For section 6, you'll do a quick review of equation types from first year chemistry. Remember, when you're doing compound formulas, these 7 elements are always diatomic. So if the equation mentions hydrogen gas, you write H2. Bromine liquid, you write Br2. Any other element, if they say calcium metal, it's just Ca, it's just single, unless they tell you otherwise. Our first reaction type can be called either composition, synthesis, combination. Either way, they just mean that you're taking 2 neutral elements, maybe diatomic, maybe not, and putting them into a compound based on their charges, which will be an ionic compound. So our first example is lithium burns in oxygen. Lithium is not a diatomic, so you're going to say Li. Elements on their own by themselves have to be neutral. Electrons match the protons, so there is no charge on the lithium yet. Oxygen, when you said combines with oxygen gas, is O2. It is a diatomic, so we have to say O2. There's a middle step here before you get to your final compound where the oxygen molecule will split apart using something called bond energy. You'll have 2 separate oxygen atoms then. And then the lithium will lose electrons, the oxygen will gain electrons, and you end up with your ions that will form your compound. Now we have to have a neutral compound, so we'll have to have 2 lithiums for every 1 oxygen. So that's your final compound, lithium oxide. Now we do have to make sure that things are balanced. You can't put in 2 O's and only get out 1, and so we have to have 2 of those formulas, formula units. And that gives us 4 lithiums, and so you have to have 4 lithiums. So do make sure that in the end you go back and you balance the charges. So in a synthesis reaction, you look at the 2 ion charges for the elements, make the correct compound, and then go back and balance the equation. A decomposition reaction is just the reverse of a synthesis reaction. You're going to take that ionic compound, CaO in this case, and you're going to break it down into the 2 elements. And so it'll look like this. Calcium oxide is heated. We do have to use something to break apart the compound. Sometimes it's heated. Sometimes it can be zapped with electricity to sort of decompose the compound. But you have to break it apart in some way. We're going to break it apart into the 2 elements that make up the compound. In this case, calcium and oxygen. Remember, elements by themselves are neutral. They do not have a charge at this point. They're going to swap electrons to kind of get everything back to neutral, but you do have to see if the oxygen and anything is diatomic, and oxygen is diatomic, calcium is not. And then you do want to go back and balance. You can't put in 1 oxygen and get out 2, so we would need 2 of the calcium oxides and then 2 calciums to balance. Remember, you don't have to put the 1 in front of the O2. We assume it's a 1 coefficient. A single replacement reaction is when you have an element and a compound. The compound is ionic, and so you're just going to sort of switch the ions and make a new compound and a different element left over by itself. And so one thing you can do is look at what ions are present or will be present. Lithium in the course of the reaction will lose an electron to become +1. In this ionic compound, sodium nitrate, you already have sodium +1 and nitrate -1, and the ions are going to sort of switch partners. Lithium and sodium can't form a compound, they're both positive. So the only thing that lithium could form a compound with is nitrate. Sodium will be left over by itself. So we're going to make the compound lithium nitrate. Li is +1, nitrate is -1, and so you get LiNO3. Plus, sodium will gain an electron, the one that lithium will lose to become positive. So sodium will gain that electron and go back to being neutral. And so we do have neutral sodium. Remember, elements by themselves cannot have charges. And at this point, you would go back and see if you could balance it. Everything is balanced on this one, so it's all a 1-to-1 ratio. Double replacement is like a single replacement twice. You not only make 1 compound, you make a second compound. You've got 4 ions involved in the reaction. We have an ionic compound of calcium +2 and O -2. And then you have a second compound, barium +2 and sulfate -2. So the ions are already charged. And we're just going to make new compounds. Calcium is already with oxygen. We could put calcium with barium, but they're both positive, so that won't work. So you have to put calcium with sulfate and barium with oxygen. And so calcium +2, sulfate -2. You get calcium sulfate. Remember to check the charges on any new compound. Barium +2 and oxygen -2. You would get BaO. And so those are your formulas. And then go back and make sure it's balanced. In this case, again, it's a 1-to-1 ratio, so you don't have to balance. It's all 1-to-1 mole ratios. Combustion reactions are different because these involve covalent compounds, not ionic compounds and diatomics like all the other types. And so in this case, you have, for the first example, CH4 and O2, that's the compound methane, usually a hydrocarbon, carbon-hydrogen containing compound. Your hydrocarbon might also have some oxygen. So you have this compound that has carbon, hydrogen, maybe oxygen in it, and you're going to burn it. You're going to react it with oxygen. And so if you notice the Lewis structures, everything is single or double bonded. You have to go in with some bond energy, which we'll actually do some calculations with in AP, break all the bonds, and then reform the final compound. And so they always make the same two products when you have combustion. No matter what that starting hydrocarbon formula is, we're always going to end up with carbon dioxide and water. So you break apart the Lewis structures at the top here, break these bonds, and then reform them into CO2 and water molecules. And so no matter what the formula of the hydrocarbon is, plus O2, you always get CO2 and water. And then we could go back and balance the reaction. We have 4 hydrogens on this side, only 2 on that side, so we'll do that. It gives us 4 O's on the right-hand side, and you have to have 4 going into the reaction on the reactant side.